Here we are going to see how to work with character arrays in C++ and how actually we can convert that code to MIPS. So we have a simple array here. It's called str. It has 6 characters. So basically it has the size is 6 and the type is character. And we have a for loop that goes from 0 to 5. So I is less than 6. And every time we're incrementing I, of course. And in the for loop itself, every time we are assigning some value, which is the hex value 10, to that index of the array. So it's gonna be str0, str1, 2, all the way to 5. So I just want to pause here and just think for a moment that what actually happens here when you're assigning this number 10 or some value to that index in your array. So the thing is that on C you have this very nice syntax that you can have your array and then you can pass any index in brackets. But what actually happens when you do that, the compiler has to calculate that location, right? So if you do, for example, str5, it doesn't like magically know that location. It's gonna calculate from the base. So always it's gonna calculate from str0, so which is like the beginning of this array, and it's gonna take like the 5th element, for example. So if you look at that, this is kind of, if you want to put it like down in the formula, this is kind of what we have. So we have the address of str0, so that's like the beginning address for this, plus I, which is the index that we are dealing with. And that's gonna be our address that this is referencing to. So that's gonna be the address of the ith element. So basically that's what happens in C++. So to do this in MIPS, we have to get this address. So we need to get this address because you don't want to like hard code those address, right? So we do have an instruction, and that is LA, which stands for load address. It takes 2 parameters. The first one is R, which is basically a register that you want to have that address into. And the second one is the label that you pass. So the label could be basically something that you define in your data section. So that could be a variable that you're passing. So let's look at how we can initialize arrays, and then we are going to actually look at this core mode. So there are 2 ways that I'm going to show you that you can initialize array in MIPS. First of all, you have to initialize them in the data section. So that would be the first part that we had in the examples. So we had data and then we had text. So the arrays go into data section. In general, anything that is in memory goes into data section. So this is basically the syntax that you have. First, you have a label, and that could be basically anything. I think you have some restriction on like if it starts with a number or things like that, but basically kind of like a variable. So that is the label that's gonna point to that memory that this gonna block. Then you have the column, and then you have a size, and that could be like, for example, .byte or .word or half word or things like that. So again, this is not a type. So in MIPS, we don't have really types. We have sizes. So you say this is a byte. And then you can pass comma separated values for each element of that array. So if you put, for example, ABC, first of all, it's gonna be the ASCII values for that. So there is a number that represents A, and there is a number that represents B and C and so on. So there is an ASCII table that each of these characters has a number. So first of all, it's gonna use that numbers automatically. And then second of all, it knows because you are passing 3, So it's only gonna allocate that much memory to accommodate these three value that you're passing. If you did like 5, it would accommodate 5 elements. So that's the first syntax that we have. You have your label, colon, the size, and the elements. The second method that we have is kind of a shortcut that you basically have same thing, label and then the size, and then you do your value and then colon with a number. So that's gonna be basically kind of repeating that. So it's gonna, as if you put a comma a comma a. So that's a two way that we have to represent these arrays in MIPS.